We've always looked up and wanted to go far. Whatever we did, we always raised the bar. Across the skies, it's been a long quest. People have tried to do their very best. We went to the moon, which was a huge step. Look what you can do when you try your best. Now it's time to go back for more. But this time, kids, it's your time to explore.
Exploring where no person has gone before can sound kind of scary, but there's no question that exploring can also be a lot of fun. Remember those days when you found your first frog or mouse in your backyard? Or maybe it was an arrowhead or old toy you found buried in the dirt. Well, that feeling of discovery is what motivates a lot of us. And today we're going to tell you about something we explored 40 years ago and are still exploring today: the moon. It's been 4 decades since humankind's first giant leap, and now a new generation is ready to explore the moon with a new, super cool instrument.
We think of the moon as being very close. It's 238,000 miles away. There are parts of the moon that we have never seen.
We know a lot about part of the moon, the part that we can see and that we've been able to take pictures of, but in the lunar poles, they're permanently shadowed craters that we've never seen into.
We want to send spacecraft there with scientific instruments on board and learn what's inside these permanently shadowed craters.
Mini-RF is a brand new, very lightweight radar instrument, and radar is something that you can use like a flashlight to look into places where the sun doesn't shine. Just like a bat uses sound echoes to work out where it's going in the dark, radar shines sort of a special kind of radiation onto the lunar surface and it gets reflected back, and we can look at that reflection to learn about what the surface is like where there is no sunlight.
Mini-RF is very lightweight. The radar itself is actually about the size of a door, and it only weighs 6 pounds. Most of what makes up the radar aperture itself is foam.
Mini-RF is 2 different scientific instruments. They'll each fly on different spacecraft. The first one is flying on Chandrayaan-1, which is a mission of the Indian Space Research Organization. It's India's equivalent of NASA. The second one is scheduled to fly on Goddard's Lunar Reconnaissance Orbiter. Both are what we call synthetic aperture radars. The purpose of those radars is to look into the permanently shadowed craters in the polar regions to see if we can detect water ice.
From a scientific perspective, you have these craters that might have ice in them, and this ice would have got to the moon by impacts from comets and asteroids.
The theory is that that water ice might not evaporate because the moon doesn't have an atmosphere and it's so very cold in those permanently shadowed craters.
The way that Mini-RF works is, as it approaches either the North or South Pole, it turns on for a few minutes and it transmits its signal, which bounces off the lunar surface, is recorded back on the spacecraft. And then the next time that the Earth can see the spacecraft, those data are transmitted back to Earth. Once the data have been processed, they look like a very long noodle image. And when they're first processed, they look like a black and white image where dark regions are smooth and white regions are rough. And then we do other processing to try and hunt below the surface to look for water ice. And if we do have ice deposits, it might be possible to use those ices as a resource. And water can be broken down into hydrogen and oxygen, and that's the same type of rocket fuel that the space shuttle uses.
Stay tuned as we share with you the thrill of discovery and learn more about the moon and its resources. And we invite you to join the adventure. After all, it's your time to explore.